Yeah, hello guys. Thanks for joining the session. Today we are going to discuss about packet flow inside the firewall. Okay. So yesterday we have discussed about some fundamentals, right? So continuation for the yesterday's class. Today we are going to discuss about the packet flow. Okay. So how this packet inspect inside the firewall. Okay. Inside the firewall, once traffic enters the firewall, how the firewall will inspect the packet, how the firewall will forward the packet, okay, allow or okay, how the packet will be inspected to allow or block that. Okay, apart from that, it will also going to verify is there for whatever the traffic that you are accessing or whatever the URL that you are accessing, is there any antivirus threats or vulnerabilities are identified. Okay, so how this firewall is going to identify all those we can discuss in this class. Okay, so we can start our class with the packet flow today. Okay, so let's suppose you have an PC. Okay, so you have a PC, you are you are accessing something on the PC. Okay, so once this, okay, whatever the traffic that you are accessing, once it reaches the firewall, okay, the firewall will be okay, this PC is connecting to one of the interface, right? So that interface will be calling as an ingress interface. Okay, will be calling as an ingress interface, okay, or inside interface. Okay, so whatever the users that are connected to the ingress interface, that we need to create one zone. Okay, let's take, I'm going to create inside zone. Okay, so which is my users that are connected to my firewall. This is, let's take, this is my private network which where I configured zone as an inside zone, and whatever the interface that is egressing out, okay, the connected to the cloud, that will be calling as an egress interface. Okay, so let's take, I have configured this egress interface in the outside zone. Okay, whatever the interface that are connected to the public or internet will be calling as an outside. Okay, this zone names are not an mandate. Okay, not this is not a mandatory that you have to use inside or outside. Whatever the name that you want, you have to define. Okay, so for my understanding, okay, I have configured my private network as inside network, right? So I'm going to configure the inside zone, and whatever the network, okay, whatever the interface that my firewall is going to connect to the outside or public, so I have defined that zone as an outside zone. Okay, so this is in your hands, and this is as you like, you can define the zones. Okay, for my understanding or for easy understanding, I am going to create inside zone and outside zone. Okay, so once traffic reaches the firewall from the inside zone, so first it will be going to an ingress stage. Okay, we have once traffic reaches the firewall, the packet has to be flow multiple stages. Okay, first one is an ingress stage, second one is an slow path, third one is an fast path. Okay, and fourth one is an application identification, fifth one is an content inspection, and last one is an egress stage. Okay, so these are the stages that packet has to be flow. Okay, and the packet has to be pass all these stages. Okay, the packet has to be pass all these stages, so that the packet will egress out. Okay, until unless the packet, okay, until unless the packet has passed all these stages, the packet will not egress out. If anything happened in between, okay, if something happened here or ingress stage or something happened in the slow path stage, the packet will not egress out and the firewall will drop the traffic. Okay, we can discuss that. Okay, and what happened in each stage. Okay, we'll discuss. First we are going with an ingress stage. Okay, whenever the traffic enters the firewall, it will be entering into the ingress stage. Okay, what will happen in the ingress stage means, once the packet received, the firewall will going to, okay, they are going to process, okay, L1, L2, L3 and L4 pack layers. Okay, so it is going to extract all these L1, L2, L3, L4 layers, and it is going to extract, okay, it is going to extract source IP, okay, destination IP, source port, okay, destination port, protocol, okay, and also the source zone. Okay, wherever the traffic enters the firewall, it will be calling as an ingress interface, right? So we have configured this ingress interface in the inside zone, right? So from this ingress interface, it will be identifying the zone. Okay, we'll be calling as an source zone, which is called as an inside zone. Okay, so what it is going to extract? It is going to extract source IP, destination IP. Just a minute, guys. Okay, so I'm back. Yeah, from ingress stage, it is going to extract, okay, all these, okay, it is going to process all these layers, and it is going to extract a source IP, destination IP, source port, destination port, protocol, and source zone. Okay, all these six parameters combinedly called as an tuples here. Okay, in Palo Alto terminology, all these six parameters will be calling as an tuples. Okay, so in the ingress stage, the firewall is going to extract all these six tuples. So after extracting the six tuples, it is going to process for the ingress errors. Okay, if there are any ingress errors, okay, if there are any errors, okay, on the L2 packet or L3 packet or L4 packet, so in each and every packet there will be a checksum, right, to in order to identify errors. So it is going to process all those things. If any error occurred in any of the layer, the packet will not be processed further. Okay, it is going to discard here itself. Okay, so if there are no ingress errors apply, okay, if there are no ingress errors identified, it is going to process further. Okay, so after extracting all this, okay, and whenever the traffic is identified coming from the IPsec tunnel. Okay, so whenever the traffic is identified, okay, we have configured some remote access VPNs or site to site, okay, VPNs we have configured. There will be a tunnel, right? So if that is a tunnel, the information will be in the encrypted format, right? So if there are any tunnel, the information will be in the encrypted format. That firewall will has to be decrypt that. Okay, in order to do that, if the traffic is identified as an IPsec, okay, IPsec or any SSL VPNs or remote access VPN traffic, so it is going to process again. Okay, it is going to process again, and it is going to extract all these tuples from the IPsec information, and it is going to process all these things, and it is going to further moving to the next stage. Okay, so these are the things that will be going to do the firewall is going to do in the ingress stage. Okay, it is going to the firewall is going to process or extract all these six tuples. Okay, just remember all these six tuples. What are the tuples that are going to extract in the ingress stage? Means source IP, destination IP, source port, destination port, protocol, and source zone. Okay, these are the six tuples that are going to extract from ingress stage from the all these layers. Okay, so once these six tuples are extracted, so what it is going to do is there will be for in every firewall there will be an flow table. Okay, there will be an flow table or session table. Okay, like how the MAC address, okay, how the switches will have MAC address table, and how the routers, okay, having the ARP table. In the same way, the firewall, okay, this firewall, the Palo Alto firewall will be having flow table or session table, where it is going to match. Okay, if there are any it is going to verify using these six tuples. It is going to verify if any existing flow is available or not in this session table or flow table. Okay, don't confuse with flow table or session table, both are same. Okay, so whenever the traffic hitting on the firewall, I told you, right, whenever the traffic hit the firewall is going to log the session, and it is going to maintain that logs in the session table. Okay, for the new traffic, there will be a no flow or session available in the session table. Okay, for the new traffic, always the packet moves from ingress storage to the slow path stage. Okay, so if we have already, okay, for this whatever the six tuples that we have extracted, if already the session exists here, okay, if already session exists here, that will the traffic will be moving from ingress to you directly fast it. This slow path will be okay, this slow path will be bypassed. Okay, so we have told, right, this is a new traffic.
Static.
Yes.
Sorry for interruption. Can you please
Hmm.
bit slower because it's going too fast.
It is going to, oh, okay, okay, no issues, I will tell you fast.
And
So
one more thing, can you please show this in practical way?
yeah, yeah,
Uh,
this practical way in the sense we cannot okay, we cannot capture in the packet capture. Okay, because this all
okay.
these things will be all these things will be done inside the firewall. Okay, we do not capture
Yes,
anything on the
yes.
packet capture, so we cannot we cannot see in the practical way, but how the process, okay, how the traffic will be inspected inside the firewall, you have to know. So that's why I'm going to explain all these things. Okay.
Mm, I think
Yeah.
we are getting confusion. Like it's
Mm.
not exact point what we are understanding. So that's the reason
Yeah,
I've
you,
asked
yeah,
you
no
this
issues.
practically.
Practical way in the sense I can show you the session table, all these things, but I cannot show all these stages because it is something doing inside the firewall where we cannot capture on the wire packet capture or seeing on the wire circle. Okay, if something is happening on the wire, okay, we can able to capture that. Okay, but this is inside the firewall, right? So that cannot possible using packet capture, but that, okay, we can also take that, but that needs some debug commands which is not necessary at this time. If possible, I will try to show all the stages once we are doing the basic lab. Okay, for now,
Okay, fine then.
if you have any questions in the flow, just let me know. You have mentioned it is going too fast, right? So I will slow up this. Okay, so if you have any doubts in any bit in between, you can just let me know. I will stop and I will explain again. Okay.
Sure, sure.
Yeah. Till till which step you have gone, or do you have any questions in between here? Anyone in the ingress stage before moving to the other stages?
Yes, Karthik,
Yes.
same to you
Yes.
itself. You are saying ingress. Ingress means what do you mean by ingress? Actually, I mean inside
Ingress.
the network means the network which is connecting to the firewall. You are saying the ingress, right?
Yes, that's correct. Whatever the private network that is connected on the interface, that will be calling as an ingress interface
So
or
that
inside
the packet
interface.
is which is going from the ingress means the inside the inside the network, the packet which is going from the inside to the outside. So the outside session is you are calling as egress, right?
Yeah, that is a egress.
Thanks. That's what I got confused. Because ingress means is there any other new word in this firewall or what? I think. So ingress is nothing but
I
an
think
inside.
yeah, ingress means inside the interface. Egress means outside interface. That's it.
Oh, thank you, thank you.
Yeah. Any questions, guys? You have
So we need to memorize this thing. In what you said, this slow path, fast path, application identification, content
yes,
inspection,
yes.
forward egress. We need to memorize all these things, but
Ye-
you cannot show in this practical way, right? That's what you said to her, like something.
Yeah, practical way. I can show you the session tables. I can show you the logs, but these stages I can't show you. But if possible, I will try to get debug commands. But okay, I will try to get that debug commands where you can see ingress stage, slow path, fast path. Okay, there are multiple debug commands is there to capture all this. Okay, but that debug commands will be uh, that will harm this firewall. Okay, that debug commands will need to be we have to apply the debug commands on the firewall very carefully. If anything went wrong, the debug commands, okay, that will be harm to your firewall. So that's what the Palo Alto will not provide any debug commands to the whoever joining or in the entry level or there whoever L1 L2. So these debug commands will helpful. Okay, whoever seniors or who are very much, okay, very much into the Palo Alto. Okay, So they in presence of okay seniors or L3 engineers, these debug commands will be executed on the firewall. For entry level engineers, they won't provide okay any debug commands, okay, because that debug
You are
some debug can.
absolutely correct, Karthik.
Yep.
Yes, you are absolutely right.
Yeah, yeah. So that is the reason we cannot see practically these stages, but you have to memorize once traffic enters into the firewall, what will happen first and what will happen next. If there is no session in the session table, which stage it will be enter, and if the session is already exist in the session table, which stage it will be enter. You have to memorize that. So just learn this process and memorize. If possible, I will try to get those debug commands and I will show you how the packet will flow, okay, inside the firewall. Okay, so I'm moving forward with the slow path. Okay.
Hello. One more thing. Here we can like so in the PPT or like in the presentation, you are writing down some
Mm-hmm.
inside and outside. So better you can write it down in the notepad or any other. So if you write it down here, we will confuse, bro.
Yeah, sure. I will write it down in the PPT or Paint. Okay.
Yeah.
So till now you have understood, right, till ingress stage. So from here, you are trying to send some traffic. Okay, once traffic reaches, so we'll be having this interface which will be calling as an ingress. Okay, and this is our inside zone. Okay, this is our outside zone, and this is our egress interface. Okay, and here first thing it will be entering into the ingress stage. Okay, what it will be what it will be doing in the ingress stage, it is going to process all L2, L3, L4 packet, and it will be extract source IP, destination IP, source port, destination port, okay, and protocol. Also it will be going to extract source zone, okay, whatever the source zone that this inside interface is available, it will be extracting that with these 6 tuples, okay, and it is going to check the ingress errors. If any ingress errors are available in any of the layer or L2 or L3 or L4, it is going to check, and if there are no errors in these all layers, it is going further, or otherwise if the firewall identified any errors in this any of this layer, okay, or L2 or L3 or L4, it is going to discard the packet. Okay, discard in sense it will be going to drop the traffic, and there will be no access whatever the traffic that you are accessing here. Okay, so if there are no errors, it is going to verify if the traffic whatever the traffic reaching on the firewall is an tunneled traffic or normal traffic. Okay, if it is normal traffic with these tuples, it is going to move to the next stage, or if it is an if it is any IPsec or okay remote access VPNs where it is going to use SSL VPNs, so it is going to check whether it is a tunnel traffic or not. Okay, if it is a tunnel traffic, it is again going to encrypt that traffic, and it is again going for the L1, L2, L3, L4 processing, and it is going to extract that whatever the tunnel information that is available, it is going to extract all this source IP, destination IP, source port, destination port, protocol, and source zone will be extracted. Okay, once this tuple, we mentioned this as a tuples, right? We mentioned this as a tuples, so we will be extracting 6 tuples in the ingress stage. Okay, so these six tuples are extracted. So with these 6 tuples, it is going to check if there are any session is available in the flow table, or we can call it as a session table as well. Okay, flow table or session table. I told you, right, how we'll be having MAC table in the switches, how we'll be having R table in the routers. In the same way, we'll be also having an flow table and session table in the firewall, where it is maintaining the whatever the traffic receiving on the firewall, it is maintaining the sessions. Okay, what it will be having in the session means whatever the, okay, we'll be having C2S flow, C2S flow. Okay, C2S means, let's take this is a client, whatever the whatever you are going to access from the internet, that will be calling as an server. Okay, so what we'll be having in this C2S flow means we'll be having same source IP, destination IP, source port, destination port, okay, protocol, and source zone. Okay, so we'll be having C2S flow and also S2C flow, okay, which is coming from this side. Okay, so it will also having all these C2S and S2C will be having all this information: source port, destination port, protocol, and we'll be having here as a destination zone. Okay, I will tell you this destination zone later. So the session table will contain this information. Okay, once these tuples are extracted, it is going to check whether any session is matching with these 6 tuples. Okay, so for the new traffic, there will be a no session is available in the session table. If you have any existing sessions, will be the firewall maintain the session for that. Okay, so now we are going to access the new traffic only. Okay, for this we don't have any session in the session table. So what the firewall is going to do is, the firewall is going to entering into the second stage, which is an slow path. Okay, so what exact will happen in the slow path means, whenever there is no flow matching with these 6 tuples. Okay, whenever there is no flow in the session table or flow table matching with these tuples, it will be entering into the slow path. Okay, so what exact will happen in the slow path means, the first thing it is going to look for the route for the destination. Okay, it will going to check forwarding lookup. Okay, so it is going to do forwarding lookup or route lookup. Okay, for what the firewall is going to do forwarding lookup, route lookup means whatever the destination IP that we have extracted here, right? So whatever the destination IP that we have extracted, for the destination we have to have the route in the firewall. Okay, so in order to send the traffic out, the firewall has route to send it, right? So in the slow path, the first step is an forwarding lookup and route lookup. So whatever the destination IP that we have extracted, it is going to check whether the route is available in the route table or not. Okay, so for the destination, if route exists, okay, whatever the destination IP that we have extracted here, if the route exists here in the routing table, okay, it is processing for the further step. Or otherwise, if there is no route, okay, if there is no route existing in the route table, the firewall is going to discard the traffic. Okay, so the firewall is going to discard the traffic here. Okay, so there is no traffic going out of the firewall itself for dropping the traffic. Okay, so we have a route in the routing table. Okay, now let's consider we have a route in the route table, and we are proceeding for the next step. Okay, after forwarding lookup, what it is going to do is, it is going to do an NAT lookup. Okay, do anyone know about NAT, network address translation?
Yes.
So
For
yeah,
public IP, we are assigning the private.
yeah, we are going to translate whatever the private IP that we have, it is going to translate to the public IP, whatever the IP that we have public IP here. Okay, because why we need NAT here means, so whenever you are entering the network, it is not good, or it is we are not supposed to enter the internet or public with our private information. Okay, private IP, because if we entering the internet or public with our private network, so there will be a chance of stealing our private information, or there will be a chance of compromising our private network. So in order to protect our network, or in order to safeguard our network or private information, what firewall is going to do is, firewall, once the traffic reaches here on this interface, the firewall going to do an translation. Okay, whatever the private IP that we have using here, it is going to translate to this whatever the IP that we have on this egress interface. So it is going to translate okay. In the on the egress interface we will be having a public IP, okay. So translating our private IP to public IP, okay. The NAT will do translating our private IP to public IP, okay. So and also in this NAT we will be having two types of NAT, okay. Source NAT, destination NAT, okay. So what happens in the source NAT and what will happen in the destination NAT means whenever you configure source NAT, our source IP will be translated to the public IP. Source IP means let's take you have scenario, okay. You are trying to ping, okay, 10.10.10, okay. From 10.10 to you are going to ping 8.8.8, which is our internet, right? So this is our private IP, okay. This is a private IP, you are going to reach internet, okay. So whenever this traffic reaches the firewall, okay, this traffic with the source IP 10.10.10.1 and the destination IP 8.8.8, once this traffic reaches the firewall, what it is going to do is it is going to translate source IP, okay. In the source NAT it is going to translate source IP. Let's take I have an egress IP which is an 100.100.100.1, okay. I having 100.1 IP on my egress interface. So what it is going to do is before sending the traffic out, it will be translating our 10.10.10.1 to 100.100.100.1, and it will be sending the traffic out to 8.8.8, okay. So this is about the source net, okay. Whenever you configured NAT as a source NAT, our source IP is going to translate, okay. This is our source IP and it is going to translate to our public IP, okay. So when this source NAT will be applied means whenever you are moving, okay, whenever you are sending traffic from inside zone to outside zone, okay. So the source NAT, okay, the source NAT needs to be configured when traffic moving from inside zone to outside zone, okay. Just remember this, we have to configure the source NAT whenever the traffic, okay, whenever our private traffic moving from inside zone to outside zone. So this is a thumb rule. The source NAT needs to be configured whenever traffic moving from inside zone to outside zone. It's correct, right? We are going from our inside zone, which is our 10.10.10.1 network, and we are going out into the public where we are going to reach 8.8.8.8. So we are sending the traffic from our private network to public network, okay, from our inside zone to outside zone. So in that case the source NAT will be applied and you have to configure source NAT, okay. In that case the source IP is going to translate to the public IP, okay. So in the destination address, okay, so in the destination NAT what it is going to do means whenever traffic receiving from, okay, receiving from outside zone to inside zone, okay, this is the criteria where you need to configure destination NAT whenever traffic receiving from outside zone to inside zone, okay. So in this case once you send the traffic, okay, once you are pinging from 10.10.10.1 to 8.8, right? So it is going from inside to outside zone. So our source IP got translated. So for the return traffic, okay, we are getting an ping, okay, ICMP echo response, right? So reply, okay, we are getting echo reply from 8.8. So how the traffic will be now? The traffic will be from 8.8.8.2, we'll get from 8.8.8.2 100.100.1, okay. So we'll get the traffic like this, okay, return traffic, okay. We are pinging from 10.10.10.1 to 8.8, and before sending out it is going to translate, okay. So the reply packet will be from 8.8.8.2 100.100.100.1, okay. Once this traffic reaches the firewall from the internet, okay, from the internet, once this traffic reaches here, so it is going to change, okay. So the traffic coming from outside to inside, right? So it is going to change the destination IP, okay. Destination what it will change from 8.8.8.2, it is going to change 10.10.10.1, okay. This is how the destination NAT will work, okay. So here the destination IP is going to translate, okay, whatever the public IP we have, it is going to translate to 10.10.10.1, okay. This will be happen in the source NAT and destination NAT. Source NAT means source IP is going to change, destination NAT means destination IP is going to change, okay. Understood? Do you have any clarification? Do you need any clarification on this?
We can call this an inbound and outbound rule also.
Yeah, we can also call that, but as Palo Alto terminology, we can call it as source net or destination net.
Okay.
Yeah. Whenever the traffic leaving from inside to outside, we'll be calling as an outbound, right? Whenever the traffic receiving from outside to inside, we'll be calling as an inbound. Okay.
Inbound.
You can also treat like that, but as per the Palo Alto terminology, we can call it as an source net, destination net. Okay. Any other questions, guys? Before proceeding further. Okay, I will take it as no. And see here in the second step, the NAT lookup will be happen. Okay, NAT lookup will be happen, and what it will do, whether if it is a source NAT, what it is going to do, it is going to simply translate our private IP through the public IP, and it is sending the traffic out, and it is moving to the third step. Okay, we'll be having third step in the slow path. Okay, if it is a source net, okay, just remember, if it is a source net or if it is the traffic moving from inside zone to outside zone, so we are doing the source net, right? It simply can translate our private IP to public IP, and it will be moving further. Okay, if it is a source net, then what will happen if we have a destination net? Okay, if we have configured a destination net, or if the traffic coming from outside, okay, from our outside zone to inside zone, what will happen means, first it will be going to change our destination IP. Okay, it is going to translate our 10 100.100.100.1 to 10.10.10.1, and after that what it will be going to do is, once it changes, once the IP is translated, the destination IP translated, it is again doing the forwarding lookup. Okay, it is again doing forwarding lookup. Why means, the destination IP was changed, right? So the destination IP was translated now, so for that translated IP, so the firewall again going to do an forwarding lookup, and will be going to check if there are any route exist for this 10.10.10.1, which is the translated IP. Okay, if the route is exist for this 10.10.10.1, the firewall will proceed further to the next step, or otherwise the firewall will going to, if it is no, the firewall is going to discard the packet here. Okay, discard the packet here. Okay, in the forwarding, okay, in the NAT lookup, there will be a source NAT, destination NAT. In the source, if it is a source NAT, it simply change the source IP and it is proceeding further. And if it is a destination NAT, first it will be going to translate the destination IP, and for the translated IP it is going to check if you have route in the routing table or forwarding table or not. Okay, if it is a route exist in the forwarding table, the firewall will proceed for the next step, or otherwise it is going to discard. Okay, this is what happened in the NAT lookup. And the third one is an policy lookup. Okay, so once this NAT lookup completes, it is going with the policy lookup, which will be calling as an security policy. Okay, or security rule, or in your terminology we can call it as an ACLs. Okay, so all will be, the terminology will be different, but the concept is same. Okay, so it is going to look for the security policy. Say here I have forgot one thing to tell you here. So in the forwarding lookup, okay, it will be going to identify the route, right? So it is going to identify the route to the destination, and with that route it is going also the exit interface, right? It is also going to identify exit interface, which will be calling as an egress interface here. Okay, once it is identify the egress interface or exit interface, and it is going to extract the seventh tuple called, okay, destination zone. Okay, we'll be calling as a destination zone, where our egress interface lies. Okay, so once it is identify the route, it is going to identify this is my exit interface or egress interface, and it is going to extract which zone it is lies. Okay, in which zone this egress interface lies. Okay, it is it is going to extract this outside as a destination zone. So this is a seventh tuple. Now we'll be having all the tuples, okay, along with the six tuples in the ingress zone. it is going to add the seventh tuple for that, and it is going to look for the security policy. Okay, for all the seven tuples, okay, for all the seven tuples, it is going to look for any security policy matching with this all the seven tuple or not. Okay, so if there is any policy matching, okay, if there is any policy matching with the seven tuples, okay, so it is going to check the action. Okay, it is going to check the action, so whether the traffic has allow or the traffic has to be blocked. Okay, so if it is an allow, the traffic is going to allow and it is further proceeding for further steps. And if it is a if the security policy, okay, if any of the security policy is matching and the action set to be blocked, the traffic will be blocked here. Okay, the traffic will be blocked here in the third step of the slow path, and the traffic will not be proceed further. Okay, so here in the firewall, in the Palo Alto firewall, we'll be having multiple policies. Okay, let's take, I have a firewall, and in my firewall I have configured okay, 1 2 3, likewise I have 100 policies. Okay, I have 100 policies. So how policy lookup will happen means, the policy lookup will be happen from top to bottom. Okay, the policy lookup will be happen from top to bottom, where once traffic enters the firewall, okay, it will be going to for the policy lookup, right? First it will be check the first policy first. Okay, so whether this policy is matching with my seven tuples or not. Okay, if it is matching, it will be stop further policy lookup, and it is going to check the action. Okay, based upon the action, it will allow or it will be drop the packet here. Okay, and if this policy is not matching with the seven tuples, it will be coming to the second policy. Okay, and it is going to check if this policy is matching with my seven tuples. Okay, whatever the source IP, destination IP, and what is my protocol. Okay, and source zone, destination zone, all this. Okay, all these things is going to match with this policy. And if this is not, okay, if it is second policy is matching, it will be stop proceeding further, and it is going to check the action, and likewise it is going to allow or block. Okay, if this is not matching, okay, if this is not matching, it is coming to the third policy. Okay, until it is matching the policy, it is going further going to check. Okay, until it is matching, it is going to check till 100th policy. If 100th policy is also not matching, there are two default policies will be there. Okay, whatever the 100 policies that I have configured, my tuples are not matching with this all these tuples. And if this no, if the 100 policies are not matching, we'll be having two different policies. Okay, interzone policy and intrazone policy. Okay, interzone means different zones. Okay, different zones, the traffic coming from one zone to going to the other zone. Or intrazone means within the zone. Okay, within the zone. And if it is the traffic, okay, if the traffic going from one zone to another zone, it will be going to hit this interzone, and by default interzone will be blocked. Okay, I told you right yesterday while we are discussing about the zones. So we have discussed about the by default the traffic will not be allowed between the zones, but the traffic will be allowed within the zone, right? So if the policy is not matching with all these, okay, all these policies, okay, if my traffic is not matching these 100 policies, it is going to check interzone or intrazone. Okay, if it is a interzone, it is going to block. If it is a intrazone, it is going to allow. Okay, intrazone will default allow, and intrazone is default allow, and interzone is by default it is blocking. Okay, so this is the thing that is going to happen in the policy lookup. Okay, once policy lookup is done, and we have okay, we have matching policy, and we have set the action allow, so the traffic will be allowed here. So before moving this, okay, before moving further, what it is going to do is, it is okay, it is going to install the session in the session table. Okay, once the policy lookup will happen, and if we have in particular, okay, we have a specific policy that is matching with our seven tuples, and we have set the action allow. So before sending the traffic further, it is going to install the session. Okay, install the session in the session table. Okay, so it is going to install the session in the session table. Okay, how we have discussed here in the flow table, right? How we have discussed in the flow table. So likewise, it is going to install the C2S flow and S2C flow. Okay, this is a session table, and once the slow path is complete, it is going to install the session in the session table. Okay, that is the reason if you don't have matching session with the 6 tuples, it is moving to the slow path. It will be proceeding all these 3 steps, and once all these 3 steps are validated and successfully completed, it is going to install the session in the session table. Okay, now once this session install in the session table, it is moving further for the fast path. Okay, so this fast path will be mostly for our return traffic. Okay, return traffic in the sense whatever the traffic, okay, we have sent an our request, and once the traffic replies, right, once our destination replies, it is coming directly entering into the fast path. Okay, and in the fast path, if the traffic, okay, if the session is already exist, I told you, right, it is entering into the fast path. And in the fast path as well, the firewall is going to process L3, L1, L2, L3, L4 processing, and it is going to extract all the 6 tuples again, and it is going to match the traffic, right? So, and we can see that traffic is already exist. And next thing, what it is going to do is, it is again going to do an NAT lookup. Okay, it is again do an NAT lookup here in the fast path, because the traffic is coming from outside, right? The traffic is coming from outside, so it is also going to look for the NAT lookup. And first it will be going, if obviously if the traffic is coming from outside, it is obviously going to do an destination NAT. Okay, it is going to do an destination NAT, and for the destination IP, okay, it is going to do an destination NAT, and also it is going to check the route. Okay, it is going to verify if we have route for the destination IP, translated destination IP or not. Okay, if the route exists in the route table, it is going to proceed further, or otherwise the packet will be discarded here. Okay, the packet will be discarded here. Okay, so after that, what it is going to do is, if it is an HTTP, okay, if it is a normal traffic, it is really going to do. If it is an HTTPS traffic, okay, HTTPS instance, whatever you are using on the browser. Okay, if it is an HTTPS traffic, let's suppose I am browsing HTTPS www.facebook.com. Okay, if it is an HTTPS traffic, what it is going to do is, it is going to verify if any SSL decryption is required or not, configured or not. Okay, we'll discuss more about this SSL decryption in the SSL decryption class, but just remember that if it is an HTTPS traffic, the firewall is going to verify if any decryption, say SSL decryption policy is configured or not. Okay, so if the SSL decryption policy is configured, it is going to decrypt this traffic. Okay, decrypt this traffic, and it is going to identify the, because this HTTPS means HTTPS traffic will always be encrypted. Okay, whatever the whatever application or whatever you are accessing here, it is already encrypted if you are using HTTPS. Okay, so in order to identify this traffic, the firewall has to be decrypted, right? So the firewall will check if any decryption policy is configured. If the SSL decryption policy is configured, it is going to decrypt the traffic, and firewall is going to identify it as an Facebook traffic. Okay, so see here, the firewall is going to decrypt this SSL traffic, and whatever the HTTPS traffic that we have received, and it is going to identify the application as an Facebook. Okay, so in the fast path itself, the firewall is going to identify the application. Okay, by decrypting the traffic. By decrypting traffic, the firewall is going to identify the traffic as an HTTPS traffic, and it is going further checks. Okay, if the traffic, okay, if the firewall is not going to identify, how the firewall is going to identify this as a Facebook traffic means, in the firewalls, okay, in the firewalls, all the application database exist. Okay, there will be an app database. Okay, where application is identified. Okay, we'll be calling as an app ID or app application identification. So how it is going to identify the application means, we have an application database where all the signatures are available. Okay, all the application signatures are available, and once it is okay, once it is decrypted traffic, it is going to match if any signature is matching with this application or not. Okay, so we are using Facebook, right? Obviously, in the application database we will be having application signature, and the firewall is going to match with that signature of Facebook application signature, and it is going to identify as an Facebook application. Okay, so once the firewalls identify the application as Facebook, okay, if okay, let's remember this thing. In the fast path itself we can identify the application. Okay, we can, in the fast path itself we can identify the application. If the okay, if firewall identify the application in the fast path, it will going to skip the application identification. Okay, we'll be having next step, next stage as an application identification. Okay, so once the firewall identify the application in the fast path stage, it is bypassing the application identification, and it further moving into the content inspection. Okay, it is moving to the content inspection. Okay, so this is all, this is for general applications where we'll be using where we'll be having all the applications internally. Okay, so let's suppose we have also have an option to configure okay, we will be also have an option in the firewall where we can configure our own application. We'll be calling as a custom applications. Okay, so where these custom applications, the firewall will not be having any signature in the application database. Okay, so if you have configured any custom application, okay, let's suppose I have configured my application. Okay, TB networks. Okay, I have configured my application. Okay, TB networks. Okay, let's suppose I'm accessing www.tbnetworks.com. Okay, and what this firewall is going to do is, first it will be decrypting the traffic, and it will be identifying the traffic as an TB network traffic. Okay, so it is going to check if any available, okay, if any matching signature is available in the app database or not. Okay, so these are the custom applications where we cannot see the signatures in the application database. Okay, so in that case what firewall is going to do is, if the signature is not identified, okay, if the signature is not identified in the application database for this TB network, it is going with the application identification stage. Okay, so if it is a facebook.com, it will be obviously having a signature in the application database, so it will be going to scale application identification, it is moving to the content inspection. Okay, now let's take, I am accessing TB networks, and we don't have any signature in the application database. So now I'm going to do is, I am going to entering into the application identification stage. Okay, what will happen in the application identification stage means, so we have manually, okay, we have manually configured application, right? So it will be going to check if any application override configured or not. Okay, if it is a custom application, okay, if it is a custom application, and we have to configure application override. So what will happen if we configure application override means, because we already know this application is an trusted one. Okay, if because we are configuring manually, so we can know that this application is a trusted application. Let's wait, someone is joining. Yeah, and we can know that this application, okay, this TB network application is an well-known application, and I'm going to trust that. Okay, so what it is going to do is, it is going to check if any application override is configured or not. So we have to configure application override if it is a custom application, and what firewall is going to do is, if the application override is configured, it is skipping the L7 processing. Okay, it is skipping the L7 processing. So why it is skipping the L7 processing means, we already trusted this application, and the firewall no need of processing for this L7 processing. If it is an application that is identified with the signature, the firewall will be going to check, it will going for the L7 processing, and it will be identifying if any antivirus or malwares are available on that particular application. Okay, so this is already customized application where I am going to trust. So the we are going to bypass this L7 processing, and directly it is going to it is directly going into the egress stage. Okay, egress stage in sense, it is we are sending the traffic out. Okay, so it will be going to identify the application, and sorry, it is going to check the application override is configured or not. And if application override is configured, it is the firewall is going to skip this L7 processing, and it is going to check further steps. Okay, and now, okay, application override process complete. Okay, And in the application identification stage, the firewall will also going to check the security policy, okay, because I told you, right, the firewalls, okay, these next gen firewalls will be also monitor, okay, will be also control the traffic based upon the applications, right? So it is going to check the security policy if my TB network application is allowed in the security policy or not, okay. It is going to check my TB network application is allowed in the security policy or not, okay. So if the policy, okay, if we have a security policy that matching with my application, and it is going to check the action, okay, it is going to check the action, and if the action is allowed, okay, if we have our security policy with the action allow, my TB network application is going to access, okay, I'm going to access the TB network, or otherwise if it is a block, it is going to discard the it is going to discard the traffic, okay, whatever the network, okay, whatever the TB networks that I am going to access, it is going to block the traffic here, okay. So see here, these are all the checks whenever the traffic enters the firewall. In each and every stage, the firewall is going to check whether it has to be allowed or not. If whether it has to be allowed or not. If the route exists, it will be going to further. If the route does not exist, it is going to discard. And in the security policy, it is going to check whether it has to be allowed or not. So these are the series of steps that firewall is going to verify whether our traffic is going to send, okay, the traffic is going to send out, or we have to drop the traffic in the between, okay. So this is the security policy lookup will happen in the application identification set. If it is allowed, okay, the firewall is proceeding for the next step, which is an content inspection. And if it is if you have configured an policy with a block, so it is going to discard that packet here, okay, discard the traffic here, okay. And next thing, in the content inspection, okay, now we have an traffic with security policy with allow. So what it is going to do is, it is going to further processing with the content inspection. So what will happen in the content inspection, right, whatever the application that we have, it is going to verify for, it is going to check if any antivirus or malware or threats, okay, or any vulnerabilities are identified, okay. It is going to verify all these things in the content inspection. And if nothing is identified, okay, so what it is going to do is, whatever the traffic we have decrypted here, right, so here this HTTPS traffic, the firewall is going to decrypt, right. So whatever the traffic it is decrypted, it will be re-encrypting here, okay, in the content inspection. If there is no antivirus, okay, if there is no malwares are identified here, the traffic will be re-encrypted here, okay. This is only an SSL traffic, okay, this is only SSL traffic which we have decrypted here in the fast path. So in the content inspection, it is going to re-encrypted, okay. So if we have not identified anything, okay, any antivirus, malware or threats, okay, it is going to re-encrypt the traffic, and it is proceeding further. Or if we have, okay, for this, okay, for this application, or for this application, if the firewall is identified as a threat, or if the firewall identified any antivirus for that, so what firewall will do is, the firewall will discard the packet here, okay. The firewall will be discard the packet, and it will be not sending out. So if anything is not identified, it will be re-encrypting, and it will be proceeding for the egress stage, okay, it will be proceeding for the egress stage. So what will happen in the egress stage means, whatever the things that happen in the ingress stage, okay, in the ingress stage, what happen if it is an IPsec traffic, so it has decrypted, right, the whatever the IPsec traffic that it has, it is decrypted, right. So in this egress stage, what it is going to do is, that IPsec traffic is re-encrypted here, okay, whatever the IPsec or SSL VPN traffic we have decrypted in the ingress stage, it is going to re-encrypt here, okay. And the next thing, it is going to check if any cost policies are applied or not, okay. I think you have well, okay, so do you aware of this cost, quality of service, anyone?
No.
Okay, so see here what cause will do means it will be limiting our the bandwidth. Okay, if it will be limit the bandwidth for the users. Okay, it will be limit bandwidth for the users. Let's suppose we are getting, okay, let's take you are using of unlimited recharge, right? So what it is going to do is let's suppose we are getting 100, okay, okay, 1 GB of speed from the internet, okay, from the internet, but we have multiple users inside. Okay, let's take I will take the scenario. Okay, I have a firewall and I have multiple users connected. Okay, I have multiple users connected and my firewall is connected to the internet. Okay, from internet we are getting 1 GB of speed. Okay, I'm getting 1 GB of speed internet. So what I'm going to do means I have to limit the users to use only 100 Mbps. Okay, I'm going to set the limit for the users need to use only 100 Mbps, so that I will be accommodate remaining 100 Mbps. Okay, 100 Mbps to the other things. Okay, so what we are going to do is we are going to create a cost policy where, okay, you can mention the source IP, destination IP. Okay, and you have to you have to mention what is the limit for that. Okay, so I'm going to limit this speed for the user for 100 Mbps, right? So I'm going to configure this and I'm going to attach this on the egress interface. Okay, always you can okay, always you can what we can do means this cost policy will always be applied on the egress interface, because the firewall will be having connected egress interface to the internet, right, where the firewall is going to send the traffic out. Okay, so before sending, the firewall is going to verify all these things. Okay, that is the thing the firewall is going to verify in the egress stage. Okay, so we are going to attach this cost policy, whatever the cost policy that we have configured by limiting the bandwidth to the user. So we are going to attach this on the egress, okay, exit interface or egress interface, so that in the egress stage the firewall is going to check the policy, cost policy, and if any cost policy is applied, it is going to limit the bandwidth to the users. Okay, so it is not providing the total 1 GB of speed, so it is going to limit the 100 Mbps. Okay, that is the reason once you, okay, once the data is reached, okay, the maximum data is reached, you are getting only 16 Mbps or 12 Mbps or 10 Mbps, whatever they have configured, the data will be reduced, the speed of the data will be reduced by using this cost policies. Okay, so once this all the checks are done, okay, the firewall is going to send the traffic out. Okay, so now all these checks are done and now the traffic will be sending out. Okay, this is all the process that firewall is going to do whenever the traffic reaches the firewall and when the firewall send the traffic out. Okay, if the traffic comes out means the whatever the traffic that we are sending has qualified all these steps. Okay, if you have not seen the traffic on the egress interface, or if you are not seeing any traffic coming out, okay, if you have discarded in between, maybe something is happening in between. Okay, so that we need to identify, we can discuss that in the troubleshooting steps. So just remember this, in order to whatever the traffic received on the firewall, and we have to send out, right? So in order to send the traffic out, the whatever the traffic that we have sent, the traffic has to be qualify all these steps. So if all the steps are qualified, then only the traffic, the firewall will send the traffic out. Okay, so these are the things that are going to happen inside the firewall, and the traffic or packet will has to be processed all these 6 stages, and the traffic will be sending out. Okay, so do you have any questions or queries on this?
Yes, please. Can you show me the picture which you took the earlier in the first?
Yeah, this is the one.
Yes. So if the packet is going from the slow path,
Hmm.
which you said the source net and destination net, right? So
Hmm.
the packet is going from the source net. Suppose if the packet is coming from the out, not from I mean not going from the inside.
Hmm.
If the packet is coming from the outside,
Hmm.
the which path it will select the from the outside?
From the outside, if okay, if let's see. Okay, let's see for this is a firewall. Okay, this is a firewall. So this is your inside server. Okay, this is the inside server. You are sitting somewhere in the public. Okay, you are sitting somewhere in the public, and you are trying to access whatever the resources that are available inside. So in this case the traffic, okay, we are initiating the traffic, right? We are initiating the traffic first, so we are trying to access this server. Okay, so in this case the traffic coming from our outside, okay, to the inside, right? So in that case also it will be okay if the session is not exist here in the firewall, whatever the traffic going from inside or outside, if the session is not exist, it is going into the slow path only. If the session is already exist for the traffic, okay, whatever the tuples that we have extracted, if the session is already exist in the firewall, it is going to the fast path. Understood?
So in that case, okay, it will choose the path depends on the session's table, right?
That's correct. If the session is already exist, okay, if the session is already exist, it is going to the fast path, and if the session is not exist in the firewall, it is going to the slow path.
Okay, thank you.
Yeah. Any question, guys, before proceeding
Okay. What
further?
do you mean by, see, you said the TB networks
Hmm.
is in a custom application, right?
Hmm.
So, what is mean by custom? I mean, so that application doesn't have the signature. That's
Oh,
right.
yeah.
What do you mean?
Yeah,
So
actually,
in that case, that application will go forward the next stage. What you said, application
application identification.
identifier.
Hmm. Yes, yes.
So what about the Facebook application has having the signature, the thing?
Hmm.
So it will go directly to the content inspection, right?
Yeah, we because in the fast part itself we have identified the application, right? In the fast path it is going to decrypt the traffic, and it is going to check what is the application, and it is going to match if the signature is available or not. And if the signature is available, it will be the firewall is going to identify that application, and it is skipping the application identification stage because we have already identified the application, and it is going to skip the application identification stage, and it is directly moving to the content inspection.
Okay, so by default, the application database will available in the firewall, or we need to configure all those
No,
database
no,
app
no.
database
It
in
will
the
all
firewall.
it by default it will be pulled from the internet. Okay, once you configure. Okay, once you turn off the firewall, and once you connect whatever the management interface that you have connected, so it will be pull up all the application database from the interface. Sorry, internet, and it is going to store in the application database. I will show you. Okay, on Monday we'll be having
So
a lab.
it's
Yeah,
by day, what to say, automatically it will learn the app database, right,
yeah, that's correct.
through internet.
Yeah, that's correct.
So in that app database, it will have the signatures and
Mm.
the app ID information, right?
Yeah, that's correct.
Okay. Thank you, Karthik. Thank you. Thank you.
No issues. Yeah, guys, any questions?
Bro, if we turn off the firewall, so like as usually we can access, like if we for startingly restricted any applications,
Mm-hmm.
if we turn off the firewall,
Mm-hmm.
so we will access any website so that we restricted starting.
No, no. Can you repeat that question once?
Like uh, so in a organization
Mm.
like uh, we some people like restricted some application like
Yeah.
Play Store
Yeah.
and Chrome.
Mm.
So if uh, we shut down the firewall,
Mm.
so we will access those applications. Like,
No, no.
is-
If you turn, okay, we are using the firewall for the security reason, right? So
Hmm.
if you have configured application, and that is defined to not access for the users. If you turn off the firewall, the entire thing, okay, whatever you are going to access, also they are going to the users are not going to access all those things. Okay, So don't that is not an use case. Okay, you if you are using firewall, you must and should you have to be always be the firewall will always be on, so that it will be helpful to protect your network. Okay, so if you turn off the firewall, everything will be gone down. Okay, it will be a completely outage. So mostly you if you have seen sometimes, okay, I'm not, okay, you are going to hear I'm not accessing anything. Okay, before whatever you are accessing, in that case also you are not going to access anything. Okay, so in that case the firewall went down, that will be getting complete outage. Okay, so don't, okay, this is not an recommended thing. Okay, if you are using firewall, don't turn off, or it is not supposed to do that. Okay, that will turn into a complete outage.
Okay. Thank you.
Yeah.
Karthik continues to his question. So he said like when we
Mm.
turn off the firewall,
Mm.
so can we access the Play Store? He asked, right? So in this case, the internet is connected to the firewall, right?
Yeah, we can if you, okay, if you turn off the firewall, you can even you cannot access the internet as well. Okay, because
That's
here,
what.
yeah, go ahead.
That's what I was saying. So
Oh,
that the direct internet will connect to the firewall, then it will come to the inside to the network, right?
yeah,
So
that's correct.
if you shut down the firewall, there is no internet to the inside people as well, right? So you cannot
Yeah,
access anything, even though Google also.
yeah, you cannot access anything. That what I said, that will be turned into a complete outage.
Yeah. Thanks.
Yeah. Any other question, guys?
Yeah, I'm audible.
Yes, Pardu.
Hello.
Yes.
Yeah, actually, as you said, we have the sessions, right?
Hmm.
The flow sessions.
Hmm.
Is there any time, if example, if Facebook.com open on
Hmm.
firewall, I
Hmm.
mean the session, is there any time duration the session will be there in the firewall,
Yeah, the
or
okay, I understood your question. That's a good question as well. Okay, so see here, the firewall will be having a sessions only for the active traffic. Okay, as long as the traffic hitting the firewall, it will maintain the sessions. Once you stop the traffic, the firewall will fetch the sessions from the firewall session table. You can
yeah, okay,
you can
then
see the sessions only for the active traffic, whatever the active traffic hitting the firewall.
yeah, if that is not active,
Hmm.
again it will check the all the process which you have explained before.
Yeah, that's correct.
Again, if it is
Again,
deactive,
uh,
yeah, right,
once, yeah,
got it.
once sessions flushes, it has to be process all the things from the first. That's correct.
Yeah, okay, okay, got it. Thank you.
Yeah. Any other question, guys? Okay, and we'll be having next concept as an session states. Okay, so we'll be having 7 states. One first state is an free init. Okay, and we'll be having active state, discard. Sorry, after init, it will be having an open state. Okay, active, discard, closing state, and closed state. Okay, so I told you, right, in every firewall there are certain, okay, certain limit of sessions. Okay, let's take I have a small firewall where I have a PAVM where I can support at least 30k sessions in the firewall. Okay, so once you initialize the firewall, all the session will be in the will be calling as an buffer. Okay, we can call it as a buffer. So all the sessions, okay, all the 30k sessions which are supposed to be supported on the firewall, it will be in the buffer that will be calling as a free state. Okay, free state instance, these all the sessions are available in this buffer and it is ready to accommodate the session once the traffic hit the firewall. Okay, so whenever the traffic, okay, whenever the traffic is hitting the firewall, and from free state to it is going to moving to the init state. Okay, so init state, and once this traffic is identified, okay, once this traffic is identified, for suppose whenever you are sending in some TCP traffic, we'll get from a SYN packet, right? So whenever the first packet is identified as a SYN, and it is going with the open state. Okay, whenever you see the SYN packet here on the firewall, so the firewall is going to move into the open state. Okay, so once a SYN packet comes in the open state, the packet receives on the firewall. Okay, the SYN packet receives, SYNAC receives, and acknowledgement receives. Okay, once this thing completed, it will be moving into the, okay, it will be going to check the security policy. Okay, once this TCP handshake completes, it is going to check the security policy. So in the security policy, if the action is set to be allow, so the firewall is going to allow the traffic, right? So once it sees the action is allow and the traffic is going to allow, so it is moving into the, from opening state to, it is moving into the active state. Okay, it is moving to the active state. If the action set to be block, okay, if the action set to be block, so from opening state to it is moving into the discard state. Okay, whenever you see the security policy, the action is set to be block, the firewall is moving into the discard state. Okay, so when the session is, okay, when session is moving to the closing statements, so we have, okay, from client to the server. Okay, you have a firewall and you have a server. Okay, so when everything is completed, okay, when everything transfer is completed between the client and the server, so any one of the server or client will sending the fin message, right? So if the firewall receives fin from any of the client and the server, it is moving into the closing state. Okay, it is moving to the closing state, and in the closing state the firewall still monitoring the traffic. Okay, still monitoring the traffic. So if, okay, in the closing state the firewall still monitoring the traffic, right? So if the firewall, okay, if the client again initiate the traffic, okay, again initiate the traffic, so from closing state to it is moving again to the active state. Okay, again it will be moving to the active state, and once this the data send completed, and again it is sending the fin message, right? It will be still in the closing state, and when the closed state will be seen, okay, when closed state will be seen means once you see the fin message from the client, and again the server also reply with the fin packet, okay, or fin bit or fin packet, so the firewall will be completely closed that session, and this closed session, whatever the session is closed, it will again moving into the free buffer. Okay, whatever the free state. Okay, and it is going to accommodate, it is going to accommodate for any new traffic or not. Okay, so whenever you see fin from one side, it is in the closing state, and in the closing state the firewall still monitor the traffic, and if any, okay, if the client or server again initiate the traffic, it is moving to the active state again. Okay, and whenever you see the fin from both sides, the firewall will be send that session to the closed state, and once the firewall send the session to the closed state, and it is going to, okay, it will not monitor anything now. Okay, it is not going to monitor anything, it directly closed the session and flush the session from the table, and it is moving to the free buffer or free state. Okay, so these are the 7 states that are seen on the firewall, but here we'll be having transition states and stable states. Okay, transition states and stable states. Okay, what is transition state, what is stable state means? The states which we can call it the transition state means it will quickly moving from one state to other state. Okay, you can see free state. Okay, sorry, you cannot see the free state, open state, closing state, and closed state. Okay, all these will be calling as in transition states. Okay, free state, open state, closing state, and closed states, because all these four will be calling as in transition states. Okay, because it will be quickly moving in the fraction of seconds, it moving from free to open. Okay, and it will be going to active, and from active to it is going to closing and closed. Okay, so we cannot see these sessions with our naked eyes, so that will be calling as the transition states. Whatever the states that we call as a stable state, that we can see. So remaining three, what will be having remaining three? Init state, active and discard. We can see these states. Okay, these are the state types as well. Okay, transition states and stable states. Okay, do you have any questions on this part? With this, we have completed this session, and we have also completed the firewall fundamentals. Any questions, guys?
Can you please once repeat the stable state?
Yeah. See here, here we'll be having transition states and table states. The states which we cannot, we will be calling as a stable states means that we can see our naked eyes. Naked eyes means in the session, okay, in the session table, in the session, okay, in the session table, along with this information, we can also see the session states. Okay, we can also see the state of the session. Okay, so where whatever the stable set that I have mentioned, right, you can see in this session tables. Okay, you can see this in the session table, whether it is an init or whether it is an active or whether it is an discard. Okay, you can see this, these three on the session table, and whatever the mention that I have mentioned as an transition states, that we cannot see in the session table. Okay, we cannot see at all, but we have to know, we have to we have to remember these transition states as well. Okay, this is about the stable states. Got it?
Yes.
Yeah, guys, any questions? Yeah, okay, guys. If you don't have any questions, we can wind up this session here, and just go through this recording once I upload. And if you have any questions still, we'll discuss this on Monday. So tomorrow and day after tomorrow, we'll be not having any classes. So what I'm going to do is, after this class, I'm going to provide the softwares that are required to build our lab. Okay. So along with that, I'm also going to share the lab setup video. Try to go through that video and install the lab, okay, in your local laptops. So if you have any doubts, you can just reach out to me on the WhatsApp, okay, WhatsApp group, whatever we have. So we can quickly, okay, I will quickly help you to resolve that. Okay, try to complete this lab setup in the coming 2 days, which is Saturday and Sunday. So on Monday we are going to do an basic lab, where that will be helpful for you if you have lab, okay, lab setup and handy. Okay, so just try to complete. If you have any issues facing in between, you can just reach out to me, I will help you out. Okay, so that's all today. Yeah, still if you have any questions.
Yes,
If you
Karthik.
don't mind,
Yeah, go ahead, one by one. Shravan Kumar, yeah.
Karthik, you just mentioned that 30K buff. What is mean by that? Is there any, I mean, application addresses or what is it? Is it in the
This
firewall?
30K in the sense, for every firewall, there are the maximum number of sessions that is going to support on the firewalls. Okay, this is the maximum number of sessions.
Oh,
Okay, if I take PA 220, like it will be going to support or 30K or 40K, around 40K maximum number of sessions. If that all the sessions complete, if the all the 40K sessions are filled up with any of the traffic, so whatever the traffic coming next, it is not going to accommodate the session. Okay, so it is going to discard until we have a free session. Okay.
okay. You mean sessions like what we are accessing from our laptop, like Google.com, Facebook.com. These are all the sessions, right?
Yes,
So
yes.
it is filled with the 30K, then it will remove the oldest one and it will, or it will remove all the entire 30K.
No, no, if you have an, okay, if you have active 30 sessions, 30K sessions, it is not going to remove, right? If you want to accommodate new, if you want to accommodate session for the new traffic, any one of the active sessions needs to be we have to discard, or we have to remove that session from the session table. Okay, if that is not, if that is not currently not an legitimate, or not in active. Okay, so in that case, we are going to we are the firewall is going to flush that session, and it is going to accommodate. Okay, so that is the maximum number of,
So
that is the maximum limit that firewall is going to support. Whatever the mentioned, that
okay.
30K, that is the maximum number of sessions that firewall is going to support.
So it will firewall will do it automatically. The flush the inactive session.
Yeah, the firewall will automatically do that inactive sessions.
Okay, thank you, thank you.
Yeah, I think Alakya, you are asking something.
Yes, I just want to know the SSL basic VPN difference.
Sorry.
IPsec and SSL difference.
You can come to know in the upcoming class. Okay, we have separate class for SSL VPN or SSL decryption, and we'll be having separate class for IPsec as well. So you can come to know. Okay.
Okay.
Yeah. Any question?
Hi Karthik, where we can see this sessions count?
On the firewall. Okay,
In,
whenever, okay, there is an when once you log into the firewall, and you can see on the dashboard itself what is the maximum number of sessions that is going to support. Okay, I will show you on Monday. Okay, I will show you on Monday what are the
okay, okay,
what are the sessions that it is going to support on the firewall. It is different with the different model. We have seen the different models, right? The number of sessions
yeah,
limit
yeah.
is going to vary with the models. Okay, so I will show you where you can see the sessions. Okay.
Yeah, usually we are facing a problem with the DSCP sessions.
Mm-hmm.
So whenever clients are not getting DSCP IP address, so
Mm.
manually when we are clearing DSCP session, the PA220,
Mm.
so it's working fine.
Yeah.
So
Might be. Yeah. Go ahead.
yeah, the buffer size, like you said, the 30K
Mm.
for it depends on their firewall model, right?
Firewall
So
model.
yeah, so just I want to check like where we can see the session is full session,
Mm.
and the new session is not building and the
Uh,
services got impacting.
okay. In the, if you want to know, you can just log into the firewall. Okay, on the dashboard itself, on the left side bottom, you can see the session count.
Okay.
Yeah.
And one more question, in packet flow,
Mm.
uh,
Yeah.
recently I faced one issue there is no return traffic from the suppose if user is trying to access the Facebook
Mm.
session is showing everything is okay
Mm.
and traffic is zero.
Mm.
Traffic is showing bytes it is showing zero and
Okay.
there is no traffic from the
Okay. Bytes
uh,
zero means whether that is an received bytes or sent bytes.
um, okay, I need to see this one
Yeah,
actually.
you need to see, because there will be a two things. Okay, received bytes and sent bytes. Okay, if it is
Okay,
received bytes, it's
okay,
zero. We are not receiving the traffic. Okay, but if you are
okay, got
if
it.
the bytes sent is zero, that we are not sending the traffic. That is issue with our firewall. Okay, so we need to verify that.
Okay.
Yeah.
Yeah, this only. Thanks.
Yeah. Okay. No issues. Any other question, guys? Yeah. Okay, guys. I will take it as no, and we can wind up this session here. Okay. So as I told you, just try to set up a lab and come up on Monday. So it will be easy for us to go. It is easy for us going further. Okay. So thanks for joining this class, and also happy weekend. Okay. And
Okay, thank you, Kathy.
we'll meet on Monday at 7 p.m. Okay. Our actual time. Okay. Bye.
Okay.
Thank you,
Thank you,
Karthik.
Karthik.